Hello everyone, welcome to free crash course for competitive exams held by Virat Hindustan Sangam in association with Manifest IAS Bengaluru. This program is inspired by Dr. Subramaniam Swamy and is convened by Ravi Shankar Sir, State Education Convener for VHS Karnataka branch. So I'm the chief mentor of your program. I have been mentoring competitive service aspirants for past 5 years. And we are dealing with the environmental section of your syllabus, and for the standard source for your environment, it is either Indian Environment by, Environment book by either Shankar IAS or PMF IAS. That is a standard book. So you can watch this program online on the YouTube channel of Virat Hindustan Sangam. On YouTube, you just type Virat Hindustan Sangam, you will get the entire course there. Then for any further queries, mentoring, guidance, if you want to get in touch with us for anything, you can join the Telegram channel. There is an app called Telegram. On that, you have to type VHS space education space forum and join the group, and you can reach out to us for anything, any feedback, any guidance, anything you want to talk to, right? Okay. So yesterday we were talking about acid rain, the phenomenon of acid rain. So acid rain, it is a pollutant. So it is a pollutant. It causes pollution in the on the ground, soil pollution, water pollution, all these things. How does acid rain comes? It is because of the mixing of sulfur oxide and nitrous oxide into the water, and it precipitates on the earth. So there are two types. One is dry deposition, another is wet deposition. Dry deposition, so it mixes with the air and directly gets attached to the buildings and trees and on the ground. That is dry deposition. If it mixes with the water and precipitates, then it is wet deposition, right? So that is about acid rain. So today we will talk about the chemistry of acid rain. What is the chemistry of acid rain? So the first is these oxides of sulfur and nitrogen. They mix, whatever is there in the atmosphere, they mix with the water, and some of them come as dry deposition and some others come as wet deposition. So for this acid rain to take place, or whether for it to take off, sunlight is very, very important. So sunlight, what does it do? Sunlight, you know that ozone, you know the layer of ozone. So ozone is created by sunlight. So ozone, sunlight acts with the oxygen, reacts with the oxygen, or oxidizes the oxygen and creates the ozone molecule. What is the formula of ozone? So ozone, it is O3, right? Ozone. So this ozone or this ozone or photooxidant interacts. This is a photooxidant. Photooxidant means what? Photo means what? Sunlight. So because of sunlight, this is formed. This interacts with the sulfur oxide and nitrous oxide, and it forms the acid rain. Later on, acid rain falls onto the ground. So with respect to acid rain, so this water from the acid rain accumulates in the lakes, rivers and all other places, especially the lakes. So what are the characteristics of the lake filled with acid rain? What are the characteristics of the lakes filled with? So there are two types of acid rain. One is natural acid rain, another is anthropogenic acid rain. Natural acid rain are, so because of volcanoes, because of the natural emission of the nitrous oxide and sulfur dioxide, it mixes with the water and returns to the earth as precipitation rain. That is natural acid rain. But because of human induced emissions, human induced sulfur dioxide and nitrous oxide by vehicular emissions, industrial emission, if the acid rain happens, then it is anthropogenic. Anthropogenic means human induced. So what are the characteristics of natural acid rain lake and anthropogenic acid rain lake? So natural acid lake and anthropogenic human induced acid lake. So what is the differences? What is the difference between the two? Andre, see, this natural acid rain, it is either brown or yellow in color. It will be either in brown or yellow in color, whereas anthropogenic will be clear water. The lakes will be having very transparent water. Here it will be having brown or red color. Right? Here you have lot of carbon. Carbon will be more. Carbon content and the organic content will be very high here, and transparency will be low. You cannot see what is there in the bottom of the lake. Here carbon content is low, transparency is high. Organic content is, see, organic content, why it won't be there? Because when acid is there, the organic content will die, right? So carbon content is low, transparency is very high. So this natural acid lake, it has low pH, and it has good buffering. Este acid is, there is buffering. Buffering means what? There are bases. What is the opposite of acid? Base. So acid and base mixes to give out what? Salt plus water, right? Your basic chemistry. So this buffering means when there is sufficient amount of bases to tackle the acid, that is buffering. So this natural acid lake has good amount of buffering, whereas the anthropogenic acid lake has poor buffering. There won't be much buffering. Then you have, here you find good aquatic life. Lot of fishes, plants, everything will be happily living in the natural acid lake, natural acid rain lake. Here it has poor aquatic life. They will die. They don't like to be in the anthropogenic acid lake. So here some of the organisms are eliminated. They become extinct. So this is the difference between the two types of lakes, right? So they might ask you, in an anthropogenically induced acid rain lake, what are the characteristics? It's a probable question in under your science and technology, environment, as well as geography. Might be even in current affairs. So next we will look at the impact of acid rain. Acid rain in the, what are the changes that is going to take place? So one is, we will look into the impact of soil. Acid rain in the, what happens to the soil? So soil, see, soil has got lot of minerals, right? It has got lot of minerals, nutrients, everything. So because of acid rain, these minerals are going to leach. Leach means they are going to get out of the soil. They are going to be removed from the soil. Leaching will take place. So soil will become what? Infertile, insterile, right? So that is, it is not good for cultivation, right? Then it decreases the respiration of organisms. In the soil only there are a lot of organisms, microorganisms. It will be difficult for them to breathe, respiration capacity or oxygen content. So soil also has a lot of oxygen content. So it will be saved in the pore spaces between the crystals of soil. Soil means these small soil particles are called soil crystals. Between the soil crystals, oxygen will be saved, which these microorganisms uses to breathe, right? When acid rain happens, this oxygen will be depleted and all these organisms will suffer from hypoxia or anoxia, that is lack of oxygen, right? So next, here decomposition will reduce. Soil, soil is the main component for decomposition, organic decomposition, degradation of the organic material. But acid rain reduces the decomposition. Decomposition won't take place. Then nitrate content, nitrogen content of the soil will also reduce. Nitrogen is very important for the plants to grow. That nitrogen content will reduce. Then not only that, so these are the effects on the soil by the acid rain. But we must feel good that Indian soils are very good. So soils good in what aspect? They are alkaline. Alkaline andre, so they are not acidic. Indian soils are basic, right? So no matter how much acid rain pours, all that acid will be neutralized. So Indian soils are alkaline or saline. Andre pH level is more than 7. So whatever the acid falls, it is going to be neutralized. So that is the quality of Indian soil. But please remember, the soils in the boreal forest, boreal or tundra forest or alpine forest, where there is a thin layer of soil. So that is cold climate. There the soils will be acidic, right? Soils will be acidic there. So then this is about the impact of soil. Then what is the impact of the acid rain on the vegetation? ಬೆಳೆಗಳ ಮೇಲೆ ಏನು ಪ್ರಭಾವ ಬೀರುತ್ತೆ ಅಂದ್ರೆ, so the yield will be reduced, the growth will be reduced, right? If a plant is going to give yield in 1 year, it will be delayed by 1.5, maybe some another 6 months. That is one effect. Then discoloration andre leaves will change their color because when acid rain falls, if it is green, it might turn to yellow or brown, right? That is one effect. Then premature aging. So suppose a tree has a life of 100 years. So that tree will become old earlier, just like how humans are becoming old very earlier because of pollution. Similarly, trees are also going to become aging. So aging will fasten up, right? Then some trees might also die because of acid rain. So this is of the effect of the acid rain. So on the vegetation, then as a effect of the acid rain on the microorganisms. Microorganisms, see these bacteria, they do not like acid rain. They are going to die. Bacteria are going to, see this point is important. For acid, bacteria, acid rain is not good. Whereas for fungi, acid rain is good. Fungus will grow properly. They are in the acidic medium. So fungus content will grow, bacterial content will reduce in acid rain. It is important. That is why I am telling you, right? So when this fungus grows, bacteria reduces, there is a imbalance in the ecosystem. So it is not good for the environment. That is one thing. Then what are the effects on the wildlife? Wildlife, animals, humans and animals. So you have this eggs by the small organisms, right? Frog eggs. Does a frog lay egg or does it give birth to living tadpole? So okay, forget it. So whichever organism lays eggs, small eggs, because of acid rain, all that eggs will be destroyed, right? Small eggs will be destroyed. Then leaching, because of the leaching of the minerals. See, when the minerals are there, it is going to help the microorganisms to thrive. But when minerals are gone, it will affect the microorganisms. Microorganisms will not grow, right? So that is one thing. Then what is the effect of acid rain on the humans? So human skin will get affected. So a lot of skin diseases will happen. Then bad smell. So because of acid rain, the surroundings will be affected with bad smell. That is one thing. Then food poisoning will happen. Bronchitis, that is respiratory disease, will take place, right? So this is all the effect of the acid rain on humans. Then most importantly, what is the effect of acid rain on metals? This is what they are going to ask you in your exam. Acid rain, how does it affect the metals? So metals will get corroded. So which is the element, which is the material which is going to affect the metals? It is sulfur dioxide. Sulfur dioxide in the acid rain affects the metals and it gets corroded. Then stones will turn black color. They will become black in color. So you know this Taj Mahal and all, right? Taj Mahal and many monuments. So historical monuments, because of acid rain, their stone are discoloring. They are changing their color, right? So we have to protect them because our history is our heritage. It is our what? Wealth. It is the real asset we possess, right? So stones will turn black in color. For that also sulfur dioxide is responsible. Then ceramics. So we have various ceramic products, ceramic architecture. So ceramic surface erosion will happen. On the ceramic surface will get corroded because of acid rain. For that, fluoride in the acid rain is fluoride is responsible for the discoloration or the surface erosion of the ceramics. Then you have textiles. So you wash your clothes, put it in for drying in the open sun. So what happens? Acid rain comes, so your cloth will get discolored. It will get faded. Your cloth will get faded because of acid rain. So for fading of cloth, what is responsible? It is nitrous oxide, NO2, right? So this is the effect on materials. Then what is the effect on pollutants? So certain pollutants. See, this acid rain doesn't increase the pollutants per se, but this acid rain acts as a trigger. So suppose there is some pollutant, mercury, cadmium, nitrate or something. So acid rain doesn't increase the amount of mercury in the biosphere. But what does it do? It acts as a triggering effect. It acts as a catalyst, so that if mercury is stored one side, so as soon as the acid rain falls on it, the mercury will start spreading in the environment. So it acts as a catalyst, acid rain. So mercury content will increase because of acid rain. Because it acts as a catalyst. Then aluminium, if it is there, that is going to leach in the environment. Aluminium leaching will happen. Then cadmium is also going to get into the environment because of the acid rain. So these are the effects. It also has a effect on lead. Lead is also going to increase in the environment because of acid rain. So all these are the bad effects of the acid rain. Then what is the measure to prevent the acid rain? How do we prevent? You give me the steps. How do we prevent? So one is add more and more bases, add more buffering capacity. That is, add more bases so that acid rain won't happen, right? So even if acid rain happens, the acid will be neutralized. That is one thing. Second thing is reduce the amount of sulfur dioxide and nitrous oxide in the atmosphere. So reduce the emissions of these two gases, then acid rain will automatically reduce. Then one more thing is towards this effect, so you know that the sulfur dioxide and nitrous oxide, they are emitted by the vehicles. So what to do? We have to increase the efficiency of vehicle engines so that SO2 and NO2 is reduced. That is one thing. And also this Bharat 6 fuel, BS6, that is also a step towards reducing the acid rain or reducing the pollutant of nitrous oxide and sulfur oxide. Clear? Okay. So this is all about the acid rain. Then we will talk about the industrial. So we will talk about the polluting industries. So acid rain got over polluting industries. So how do we polluting industries? How do we control the polluting industry? So the thing is, so with respect to controlling the polluting industries, we have a categorization procedure. So Ministry of Environment, Forest and Climate Change. So MOEFCC. This ministry has come out with a categorization procedure for the industries. So it categorizes the industry into 4 categories. One is red category industry, orange category, green category and white category. 4 categories are there. So pollution, how does the MOEFCC categorization? There are 4 categories. You should know 4 categories ide anta. So red category is very dangerous. So red category industries are not allowed to be set up in a ecologically fragile regions, that is mountain regions or coastal regions or biodiversity regions. Red category industries are not allowed to be set up. That is one thing. Orange is little bit less dangerous. Green is good industries. I mean, they are much more less dangerous. Then you have white category. White category industries, it is a new category. It is a new category. So it is a non-polluting industry. White category industries, it is absolutely non-polluting. It doesn't cause any pollution. So when an industry doesn't, see, whenever you have to set up an industry, you have to obtain a environmental clearance, EC. So first what they do, they are going to conduct an environmental impact assessment. And what is environmental impact assessment? I am going to discuss in further chapters. So environmental impact assessment, basically you understand this much, that how much impact, how much adverse impact or bad impact does the industry is going to make on the surrounding environment. So after conducting this, once the environmental impact assessment report is submitted, then they are going to give the environmental clearance for the industries, right? So for the white category industry, this environmental clearance is not required. Then this MOEFCC also has, so on what basis this 4 category of industries have been categorized andre, it is based on a pollution index. Pollution index anta ide. So there are what is the pollution index andre? It is a number from 0 to 100. So more the number, higher the pollution, right? 0 to pollution index mele it is categorizing. So this is all about the pollutants, polluting industries, also the entire polluted environmental pollution is done. Then we will move towards a new chapter, new topic, your favorite renewable energy. You have many types of renewable energy. What are name them? Solar energy, wind energy, geothermal energy, tidal energy. What else? Huh? Hydro, power, biomass. What else? Biomass, ocean thermal, fuel cells, fuel cells. So tidal energy also includes ocean thermal, or you can say it is different, ocean thermal. So these are the type of renewable energies. So why do we want renewable energy? See, today, because of the excess use of the pollutants, fossil fuel, that is coal and petroleum, there is lot of pollution, right? So you have global warming, we have climate change. From the industrial revolution today, the temperature has been increasing at a faster pace. According to Paris Climate Deal, we aim to reduce the pollution. What is the goal of the Paris Climate Deal? Do you know there is a Paris Climate Deal? When was it signed? 2015. So, Conference of Parties 21. I am going to discuss it under the environmental laws, right? So, COP 21 ಅಂತ ನಡೆಯುತ್ತೆ. That is Conference of Parties 21 under what? UNFCCC. So, when was UNFCCC signed? Rio Summit 1992. You should know these laws or else it will be very difficult, right? So, this Paris climate deal says that, see, before the industrial revolution, what was the temperature? We should reduce, so temperature has been increasing, global average temperature. So we should reduce, let's say, before industrial revolution, the average temperature of the world is 24 degrees Celsius. Now it has reached 24.5 degrees Celsius or even more. So what does this Paris climate deal say? That Paris climate thing, you have to reduce it below 25.5 degree. Andre 1.5 degree. You should keep the temperature rise within 1.5 degrees Celsius. That is what the Paris climate deal says that. So in this effort, what is, so we need energy, right? So we need vehicles to go on. We need industry to produce goods. We need so many things, right? So we cannot dispense with our comforts. So what is the alternative? Instead of fossil fuel, renewable energy is the alternative. What is renewable energy? Andre, these are inexhaustible. Andre, they are available continuously, no matter how much you use them, right? Renewable energy, you can keep renewing them. Sunlight, does it get exhausted? No. Wind, does it get exhausted? No. Right? So, you can use it as much as you want. It won't get exhausted. It is a perpetual source. Right? So, it is an alternative source of energy we are talking about instead of a fossil fuels. Right? So, these are the type of renewable energy. So, our government, with respect to renewable energy, Indian government has given a target, has set up a target that is by 2022, that is the end of this year, they are aiming to produce 175 gigawatt of renewable energy, out of which 100 gigawatt comes from what? Solar energy. 100 gigawatt from solar energy. This 175 gigawatt is very, very important. It will be directly asked in your all exams, starting from constable exam until the UPSC exam. Okay. So 100 gigawatt for solar energy, 60 gigawatt of, okay, wait 1 second, I'm going to erase all these things. So out of 175 gigawatt by 2022, so out of which 100 gigawatt by solar energy, 60 gigawatt by what? Wind energy, right? Wind energy. So this is a target they have set. So today, so we are aiming 175 gigawatt, but today the capacity is around still 90 gigawatt. So we have to increase it multiple times. But 90 gigawatt is not a small thing. 90 gigawatt is also a significant achievement. So there is a saying that aim for the stars, you will land up somewhere near the moon. What does it mean? ನಕ್ಷತ್ರಕ್ಕೆ ಗುರಿ ಇಡ್ರಿ, ಎಲ್ಲಾದ್ರೂ ಚಂದ್ರನ ಮೇಲಾದ್ರೂ ಅಟ್ಲೀಸ್ಟ್ ರೀಚ್ ಆಗ್ತೀರಾ ಅಂತ. So we have to keep good targets, sufficient targets, so that at least this much is achieved, right? Had we kept just 100 gigawatt, we would have landed somewhere be around 50 gigawatt, right? So we have to aim high, right? That is what the government has done. So first of all, we will talk about the most important form of renewable energy. What is the most important form of renewable energy? Solar energy. So when it comes to solar energy, please remember there are two types of solar energy. Two, or now we have added one more type. So basically only two types of generation of solar energy. One is photovoltaic cell. What do you mean by photovoltaic cell? Photovoltaic. So there will be some material, some solar panel. Solar panel, you inside that you have solar cells. So what does it do inside? So let's say this is a solar panel. So what does it do? Sunlight, photons are going to the sunlight is going to fall on it, which excites the, so photons are going to fall on it. So photons andre no, sunlight can be in two forms. So light can be in two forms. One is material form, or another is wave form. So material formally it is photons. Light waves contain small particles called photons. So these photons are going to fall on the solar panel. It is going to entice or it is going to energize the electrons. So the electrons are going to flow, right? So there will be a voltage differential because of which electrons are going to flow. See, let's say electrons are flowing in this direction, from this direction. So let's say this is positive, negative and positive. So electrons are flowing from this direction to this direction. But what is the direction of electric current? So it is always the opposite of the flow of direction of electron. Electrons flows from negative to positive. Andre current flows from positive to negative, right? So that is about the flow direction. So photovoltaic cell andre photo, that is light falls on it, which creates a voltage differential. Voltage difference agutte, which will give rise to the flow of electric current, right? This is a photovoltaic cell. So this produces direct current. What is direct current? So direct current, it just flows from positive to negative. That is direct current. Whereas there is one more current called alternative current. Alternative current, the direction of the current keep varying, right? So that we will study under your science and technology. So this is the first step, the first type. Next you have another type called solar thermal generation or concentrated solar power. That is the second type of generation. Solar thermal cells or concentrated solar power. So under this, what is going to happen? There is a big mirror. There will be a big mirror. Sunlight is going to fall on this. This mirror reflects the sunlight to a particular place, right? Particular fluid. So here this place will be having conduct of fluid, cold liquid. So this is a concentrated solar power mirror. So this is going to reflect the sunlight and it is going to fall on this plate, right? So here it gets heated up. So the water which is cold here, by the time it comes here, it becomes warm, right? So this is the mechanism of concentrated solar power. So the water which is cold here, it is not even warm, it becomes steam. So high pressure steam, it is going to turn the turbine. Turbine and electricity is generated. So all your big temples, right? You take the Dharmasala temple, Tirupati temple, any temple you take, they are using this method to cook the food, right? Concentrated solar power. So it is shown in the National Geography, right? You should be interested about these things, right? Not Facebook and WhatsApp. Okay. So there is so this heats a liquid, that liquid will become steam and it is going to turn the turbine and electricity is generated. So these are the two types of generation of solar power. So what is the potential in India? How much solar power can we generate? It is we have a potential of 35 megawatt per square kilometer. If there is a square kilometer of place, we can generate 35 megawatt. That is the potential we have. Why we have so much potential? Because half of the country falls within Tropic of Cancer, half of it in temperate region. So there is lot of sunlight available for India to tap into. So how much have we installed? How much? So we have a target of 100 gigawatt. How much solar panels have we installed? We have installed a capacity of 40 gigawatt. So now it might be around 45 gigawatt, right? 45 gigawatt of installation is there. So with respect to solar energy, we have a mission. So that mission is National Solar Mission, right? National Solar Mission. This comes under National Action Plan on Climate Change. When was this NAPCC formed? National Solar Mission. When was it started? When was National Action Plan on Climate Change started? Very important. 2008. All the National Solar Mission, National Sustainable Agricultural Mission, National Himalayan Ecosystem Mission, National Mission on Sustainable Agriculture, you name the missions, all of them started in 2008. Very, very important. So, this, according to this National Solar Mission, what is the goal of this mission? Andre, it aims to make India a global leader in solar power generation. That is the goal of this mission, right? So, with respect to this, there is one more solar mission. There is one more concept called International Solar Alliance. Do you know this concept, International Solar Alliance? So, International Solar Alliance. So, when was it started? So that was also started in the year 2015. 2015 will start agute. So that is when the Paris climate deal takes place. Who were the two people who started it? So France President Francois Hollande and our favorite Prime Minister Narendra Modi ji. Both of them started the the International Solar Alliance. So this was started during COP21. COP and Reno, not COP. It is Conference of Parties. Conference of Parties to what? Conference of Parties to UNFCCC. When was it signed? 1992. Yes. So this involves, they say that this, according to the International Solar Alliance, it is a grouping of 121. Right now we have around 68 countries. We have 68 or 58 countries who have signed and ratified the International Solar Alliance. So this International Solar Alliance aims to tap into 121 countries between. So what are the countries eligible to join International Solar Alliance, Andre? Only those countries which are between Tropic of Cancer and Tropic of Capricorn. These countries are called as sunshine countries, or according to the nomenclature of our favorite Prime Minister, they have been called as Surya Putra Rashtra. Surya Putra Rashtra, or the countries between Tropic of Cancer and Tropic of Capricorn. Very, very important, right? So what is the formal name of International Solar Alliance, Andre? This is not very important. They might ask. So it is International Agency for Solar Policy and Application. International Agency for Solar Policy and Application is the formal name. So what is the objective? International Solar Alliance. So what is the goal, Andre? It aims to reduce the prices. Solar panels are very, very costly. So this aims to reduce the prices of the solar panels. Then it aims to tap into technology, solar production technology. So that technology has to be made available for everyone. That is the second goal of the International Solar Alliance. Third goal is to carry out research and development. Andre solar energy produce madadike, we have to have more and more research, right? Better and better efficiency. So these are the three goals. So there is no financial assistance under International Solar Alliance. There is only price mechanism, reducing the prices, technology sharing, then increasing research and development, right? So this is about the International Solar Alliance. Earlier I told you there are two types of generation of solar energy. Now they have one more type of generation called as Luminescent Solar Concentrators, LSC. So ಏನಾಗುತ್ತೆ, see, when there is a solar panel, let's say this is a solar panel, the conversion ratio is very less. Let's say, suppose 100 joules of energy falls into it. So electricity, it will convert it just 40 joules, right? So, but this luminescent solar concentrator idiyalla, so there the energy conversion ratio is higher. The efficiency of luminescent solar concentrator is higher, right? So what is this luminescent solar concentrator? Andre, this is the thin sheet of material over large area. So solar cell do size istappa irutte at least minimum. Whereas luminescent solar concentrator, it will be just like a sheet of paper. Sheet of paper tara irutte. On that paper, the solar energy falls. When the solar energy falls on that sheet paper, so this sheet over it is a very large sheet. So when solar energy falls on this, the energy will be transported to the edges. All the edges, energy gets transported. From these edges, the energy will go to the battery, right? This is the concept of the luminescent solar concentrator. So this aims to replace the solar cells, because solar cells are expensive and also energy conversion ratio is less. So what is the advantage of luminescent solar concentrators? Andre, see, normal solar cells, they tap only direct solar energy, right? That is solar radiation, direct solar radiation matra tap madutte this photovoltaic cell, right? Normal solar cell. Whereas this luminescent solar concentrator, this aims to tap both normal, that is direct radiation, and diffuse radiation. Direct radiation andre eno? So if let's say this is the atmosphere, this is the ground, this is sun. So directly the energy is going to fall. That is direct radiation. But you have Tropic of Cancer here, Tropic of Capricorn here, andre. So here the sun won't cross Tropic of Cancer. So whatever the sun rays, they are going to fall slantly in a bended position beyond Tropic of Cancer. So here, while traveling through the atmosphere, it is going to get diffused, right? The intensity will become lesser, or it is going to spread up, right? It is going to, the solar rays are going to spread up. So because of which this is not suitable for the solar energy generation. But the beauty of the luminescent solar concentrator is it generates energy both from direct radiation as well as diffuse radiation, because both these things, it can generate the energy. So that is why diffuse. So even in cloudier regions, suppose there is lot of clouds, so clouds idaglu we won't get direct radiation, we get diffuse radiation. Then also this LSC can become useful. So this has the highest efficiency, right? So the highest energy conversion efficiency there. So this also reduces loss of absorption loss andre eno? So whatever the photovoltaic cell, PV cell gets the energy, it won't be converted completely into electricity, alva, that I told. So there is lot of heat loss or absorption loss that is eliminated in LSC. And also this provides long-term stability. Andre, see, this photovoltaic cells idre, you have to keep changing it every 1 year or 2 years. Whereas LSC, you need not change immediately. It provides long-term stability. So it is better for me to show the picture of luminescent solar concentrator so that it etches into your long-term memory, right? So let the internet open. So next we will talk about one more agency called IRENA, International Renewable Energy Agency or International Renewable Energy Association. So it is a group of 150 countries. IRENA, IRENA, 150 countries. Headquarters important. Where is headquarters? Abu Dhabi. IRENA, IRENA, please write down, it is Abu Dhabi. So what does this IRENA do? It focuses on renewable energy. So it focuses on all types of renewable energy, whether it is wind energy, solar energy, you name the energy, it focuses upon. So in that renewable energy, it wants to build international cooperation. International cooperation, it aims to have a proper policy and a government policy towards renewable energy generation. Then it aims to share the technology of renewable energy, it aims to share. Then also it aims to provide finance. See, International Solar Alliance doesn't have any financial component, whereas IRENA has a financial component. It provides financial support. That is about IRENA. So before moving towards the wind energy, we will look into Luminescent, solar, so it somewhat looks like this, very thin layer. So this guy is, see, this is a luminescent solar concentrator, just a glass. So here the energy falls, all the energy will be diverted towards the edges. From the edges the conductivity takes place. Clear? This is a luminescent solar concentrator. Okay, this might also be one. Okay, let us not. So next we will move towards the wind energy. So wind energy andre, so wind, what is wind? You know that it is a flow of air from high pressure to low pressure. So wind has lot of potential to generate energy. So the stronger the wind. So how do we decide the strength of the wind? So one is, the strength of the wind is decided by the velocity of the wind. So if the velocity is higher, the strength of the wind is higher. That is one thing. Second thing is the density of the wind. So if the wind is thicker, how does the wind become thicker? When the moisture is high. When the moisture content in the wind is high, the wind becomes thicker. So both these winds are going to, when velocity is higher, when the wind is thicker, it is going to generate lot of energy, right? I mean, energy generation potential is higher. So wind energy, so what is the conversion? It is the conversion of kinetic energy to mechanical energy to electrical. What is kinetic energy? So it is a energy by movement of air or anything, right? So that is converted to mechanical. Wind turbines move agutala, right? Then later electrical energy. So we have wind farms, concept of wind farms, where wind energy is generated in a wholesale or a large scale, that is wind farm. So there are two types of wind farm. One is onshore wind farm, another is offshore wind farm. Onshore wind farm andreno, which is on the land. So here see, setting up the wind farm on the land is less expensive and it is easier. But see, the speed of the wind actually is more over the oceans. That is why some places they are trying to set up the wind farm on the offshore as well. That is over the oceans as well, right? So there the setting up the wind farm is costlier. That is one thing. Not only that, costlier is one part, and also it is difficult. So you have to go and build over the oceans wind farm, right? So these are the two things, right? So on what factors that the wind energy depends? How much energy, wind energy we are generating another? On what factors does it going to depend? It is going to depend on speed of the wind. Wind speed, first factor. More the speed, more energy is generated. Then radius of the blade. So you have wind farm, let's say, sorry for the bad diagram. Okay, let's say this is a wind farm. So the radius is from here to here. More the radius of the blade, more energy is generated. So if the radius of the blade, the radius, if you double the radius of the blade, the amount of generated energy becomes 4 times. Andre 100 watt energy generate ಆಗ್ತಾ ಇದೆ. If you double the radius of the blade, you will get 400 watt of energy. That is why, you know, right, these wind farm blades are actually very huge in size, right? That is the second factor. Third factor is air density. Density of the air, I told you, density of the air is more energy is generated. So where does the air density is higher? Is it at the sea level or on the mountains? It is at the sea level, because see, sea level air pressure is higher. When air pressure is higher, density is higher. So as the air gets moves upward, it gets rarefied, right? It becomes lighter and lighter, because of which density reduces. So these are the 3 factors. So there are 2 types of wind machines or wind turbines. So one is horizontal axis turbine, and so horizontal axis turbine. One more is vertical axis turbine. So I'm going to show you the pictures, without which it is impossible to understand. Horizontal axis wind turbine and vertical axis wind turbine. This is a horizontal axis. Why do you call the horizontal axis, Andre? See, the axis is parallel to the ground. The axis of this, see, the center axis ideyala, that is parallel to the ground. Then you have vertical axis. Andre, see, see, this axis is, it is parallel to the ground. Grounding idre, the axis of the rotation, it is actually parallel to the ground. Whereas you have one more concept, one more called vertical wind turbine. So vertical, it is like this, rotates like this. So this is a vertical wind turbine. So this is a vertical axis. Can you see this? So this is a vertical axis. See, here the axis of rotation, if ground is like this, the axis of rotation is like this, right? So out of these two, which is better? It is the horizontal axis, which is better. It is easier to construct. It generates lot of energy. So that is why horizontal axis is better. So this is about the types of wind energy. So it will be asked in your exam, what is the potential of wind energy? So they say that above 100 meter above the ground level. See, why windmills are, wind turbines are very tall, and why are they tall? Because the velocity of wind gets higher as we move upper, right? So if the windmill is 100 meter above the ground level, the potential in India for generation is 302 gigawatt, right? We are just aiming for 60 gigawatt from wind energy. So the total potential is 302 gigawatt. So we have a National Institute of Wind Energy. So to tap into the potential, we have one National Institute of Wind Energy. So it has produced a map called Wind Energy Map, LL Wind Energy, where so you take the coastline, entire coastline, the wind energy potential is higher. Why? Why only coastlines has higher wind energy? Moisture is one thing, but the next thing is there is offshore and onshore wind. So I've told you, so there is a diurnal change in the direction of the wind. Daytime, the wind blows from sea to land. Nighttime, from land to sea. So all the time the wind is blowing. That is why coastal areas are good for wind energy, right? So which is the state with highest potential in generation of wind energy? Wind energy. It is Gujarat, my friend, it is Gujarat. All this Gulf region. See, why Gulfs are good for wind energy, Andre? So you know, Gulf, Andre, it is a, what is Gulf? 3 side land, 1 side water. Let's say this is a Gulf. So Illenaru, if you put a wind turbine, See, here it is good. Why, Andre? The wind is directed within the Gulf. So, it is good for wind energy. Gujarat is first potential. You will be amazed to know that the second highest potential is Karnataka, right? Karnataka. So, it is this question factual they are going to ask, right? So, but when it comes to see, I am talking about potential. What you told is right. Tamil Nadu is right. But when installed capacity, yaar jaasti generate ಮಾಡ್ತಾ ಇದ್ದಾರೆ at present, it is Tamil Nadu which is generating first, Maharashtra second, Karnataka third. But when it comes to potential, it is Gujarat. Actual generation, it is Tamil Nadu, right? So, with respect to wind energy, we have a policy called National Offshore Wind Energy Policy. Offshore Wind Energy Policy 2015. So, offshore andre away from the land, we are trying to produce the wind energy. Which ministry has given this policy? So, wind energy, solar energy, all this energy comes under which ministry? Ministry of Power, Ministry of Environment. There is a ministry called Ministry of New and Renewable Energy. Please note down. Ministry of New and Renewable Energy. That under all this renewable energy comes under this ministry, right? So, National Offshore Wind Policy says that we can generate wind energy up to 200 up to the exclusive economic zone. What is exclusive economic zone? What is the distance? 12 kilometer is territorial sea. Exclusive economic zone 200 nautical miles from the baseline border, India baseline, the 200 nautical miles. Adru olage whatever the wind energy we can generate anta this policy says. Then you have this National Institute of Wind Energy, I told you, no. So that allocates the, see, where all wind energy potential is there, who will give the land, who will allot that parcel of land to the generators. It is this National Institute of Wind Energy, right? That is the nodal body. It also provides finance, research and development, and also provides a level playing field for both domestic and foreign investors. That much if you know enough. So, in 2008, there is one more mission called National Wind Energy Mission 2008. So, it is part of the NAPCC. So, NAPCC, National Solar Mission, National Wind Energy Mission, all these are important. If you forget it, you are gone. National Wind Energy Mission 2008 is part of NAPCC. It addresses aims to address the challenge in the generation of wind energy, right? So this is all about the wind energy we have spoken about. Now we are going to move towards the hydropower energy. Hydropower. So what is hydropower? So when the water moves, it is going to turn the turbine and generate the energy. So where was the first hydroelectricity plant in Asia? You are right. It is Shivanasamudra. On which river? Kaveri. So you have Gaganachuki, Barachuki there, right? So it is Shivanasamudra where the first 1902 era. Okay, why was that plant set up? Hydroelectric power plant? KGF, to supply electricity to the KGF mines. So you will also be amazed. So Bangalore is the first city in Asia to get street lighting because we had a very good Maharaja Odair, right? So he was a very public friendly Maharaja. Also we had very good divans here. You take Charadam Vishwesharaya, you take Mirza Ismail, you take Arcot Ramswamy Madliyar. Every one of them are very good divans. They were very public friendly, and also you take the Odair, Krishna Raja Odair, whoever it is, all of them are very public friendly. We are actually fortunate. Look at Hyderabad Nizam did all the bad things, always enjoyed, did nothing for the people, right? So we are fortunate to be under a very good ruler, right? Okay, now it is democracy, no ruler, nothing. So hydropower, so it is a conversion of kinetic energy to mechanical energy and mechanical energy to electrical energy. So this is the cheapest and cleanest form of energy. It is very cheap, right? So what are the types of hydroelectric generation? So there are three types of hydroelectric generation. One is a impoundment type, IMPOUNDMENT. What is impoundment? So there is a river, you are going to build a dam, store the water in the reservoir, then make the water flow through a turbine. So this is impoundment, that you are going to build a reservoir and channelize the water through the turbine and generate the electricity. All your KRS dam, everything is of this type, right? So that is the impoundment type of electricity generation. There is one more type called diversion. Diversion. So on this Chenab river, Chenab, where is Chenab? Jammu and Kashmir. So Chenab river, you have a run of diversion type of electricity generation. Ratley Hydroelectric Power Plant. So Ali on Chenab river. So Ratley. So it is diversion type is also called as run of the river. What is run of the river, Andre? I'll show you. So suppose a river is flowing like this. So they are going to either they are not going to build a dam. Put a turbine directly here. So river will be flowing, electricity will be generating. It is run of the river. Or if the river is very big, what they are going to do? They are going to take only small part of the river outside, divert the river and keep the turbine here, generate the electricity. Then later after, this river joins the main stream. So this is also a diversion type or run of the river type. Then you have one more type called pumped storage type. Third type is pumped storage. So what is pumped storage? So what happens during the monsoon time? Monsoon time, there is lot of flow of energy. So flow of water, what they do? They will generate the electricity. So they are going. They will generate the electricity. Also during the end of monsoon, there will be lot of electricity present. So what they will do? So let's say this is a dam. The dam water is flowing from here, right? What they will do? They are going to pump it to a reservoir again, pump the water again. So when lot of electricity is available, they will pump the water back to the reservoir and store it. But during summer season, there is no water, then they are going to release the water and generate the electricity. This is a pumped storage. Isn't it similar to a battery? You will save the battery, later on discharge it. So it is a form of battery. So this is the three types. Then what is most important than this is, so we have so many power plants, hydroelectric power plants. So everywhere we have this on the Rihand Dam, you have Hirakud Dam, you have KRS Dam, you have this Bakra Nangal project, right? Gandhi Sagar, Jawar Sagar, and also you name the river, everywhere we are generating the electricity. Most of the electricity is generated on the Himalayan rivers. But in Himalayan rivers, you cannot build big dams because of the topography. So we can build small dams. That is why there is one more concept called small hydropower generation project. So what is a small hydropower project? And they are going to ask you if it is below 25 megawatt. If the generation capacity is below 25 megawatt, it is a small hydropower generation project. So small hydropower project, they are not going to build a dam. Rather, they are going to generate electricity by run of the river. I have told you what is run of the river already. Run of the river. So this has least adverse effect on the environment. See, when if you build the dam, what happens? It is going to submerge the surrounding areas, submerge the forest, and lot of animals will die. And tribal people will be moved out of the area. So when Gorur Dam was built in Hassan district, so the lot of villages were submerged. Even today, the Shettielli Church, it is submerged under the Hemavati river in the Gorur Dam, right? So that is why this small hydropower project, they are not going to build a dam, rather it is a run of the river project. It is very, very good. Small hydropower projects in India, what is the potential? And we have around 5,500 sites of small hydropower generation, right? 5,500 sites. So most of the small hydropower projects are on Himalayan rivers, because Himalaya, the gradient is steep. What do you mean by steep gradient? The slopes are steep, so a lot of energy can be generated. Because of the gravity, the water is going to flow very fast from the higher gradient to lower gradient, right? Okay, so this small hydropower project, see, dams comes under which ministry? Even I am not sure. So, whereas this small hydropower projects comes under Ministry of New and Renewable Energy. We will look at dams comes under which ministry? Dam protection under, I think it is Ministry of Power or Ministry of Water Resources. Dams in India under which ministry? Huh? Ministry of Water Resource. It is Ministry of Water Resource. Whereas small, so they say, see, there are 5,334 large dams in India. Around 5,500. Whereas small power projects also around 5,500. Small dams, see, this difference is important. Large dams comes under Ministry of Water Resource. Small dams, small hydropower comes under Ministry of New and Renewable Energy. If you forget it, you are at loss. So now we are producing 3,700 megawatt or 3.7 gigawatt of approximately 4 gigawatt of energy from small hydropower projects as of now. So this is all about the hydropower energy. Next we will talk about the ocean thermal energy. So ocean thermal energy, what do you mean by ocean thermal energy? OTE, ocean thermal energy. See, you know that the sea gets heated up slowly and loses heat slowly, right? So there is a lot of heat in the sea, right? So if this is a sea, sunlight is falling, this here it will be warmer, here it will be cooler, right? Deeper layer it will be cooler. Isn't it a difference of heat? So when there is difference of heat, it can be used for generating electricity, generation of electricity. So seas, oceans have stored solar energy. So difference between this ocean thermal energy, there is a difference of heat which acts as a heat engine. So heat, here it is warmer, it is colder. So this acts as a heat engine. We can tap the difference and generate the electric energy. That is one thing. Then you have wave energy. So wave energy, how does the wave get energy? It comes from the wind. Wave get energy from the wind. Wind is going to flow and transfer the energy to the waves. So wave energy. Then you have tidal energy. So tidal energy, what is tidal energy? So during high tide, the level of the sea increases. So what they will do, when the, see, let's say the normal level is here, during high tide, the level of the sea increases. So they are going to store this ice, they are going to build a barrier here or a type of dam. So this, only during high tide, this water will flow over this dam and get accumulated here. So what they will do, so when the water level recedes or during the low tide time, they are going to release the water which is stored here in the reservoir. So then the electricity is generated. It is a tidal energy. So this, they are going to run a turbine and generate the energy. So where do we find the tidal energy? Indra, it is in the Gulf of Kutch. They are trying to produce the tidal energy, right? So this is about the ocean thermal energy. Not very important compared to other energies. So then we will move towards the biomass energy. Biomass, what do you mean by biomass? You take the leaves, you take the dead grass, you take the dead wood, all these things, if it decomposes, it will become a biomass, right? It will become a biomass. So what they will do, see, have you watched this movie? What is this movie? Kapan of Surya. Have you watched it? Where is a NSG command? Sorry, SPG commando. So there he will be a farmer as well. So what he will do, he will build bio toilets. Bio toilets, people will be paid to go and do toilet there. So all that this thing waste, toilet waste is put to the biodecomposer, so it will get turned into manure, and that manure is used to grow crops. Human waste, that is one thing, but bio waste will also generate gas, right? Methane gas, that is used for generating electricity, that is shown in the Carbon movie, that is renewable energy. That is also a form of biomass energy. So it is a carbonaceous waste, andre from the carbonaceous waste, ellirutte timber, crops, grass, all the waste, right? So even your stubble andre, once you harvest the rice, paddy harvest madmele whatever is left behind alva, that is also biomass, that can be used to generate electricity. Adana koliyag bidbeku, then it will give methane gas which can be used for producing heat or electricity. So this biomass releases carbon dioxide. It releases carbon dioxide when it undergoes degradation, right? So even fossil fuels release carbon dioxide. When we burn the fossil fuels, petrol, it releases carbon dioxide. Even biomass releases carbon dioxide. So then why should we use biomass? What is the advantage? One is it is renewable. We can have lot of biomass. We can grow it. We can use it. Second is, see, these fossil fuels, they have captured the carbon from millions of years. And earlier times, millions of years ago, whatever the carbon was captured, that will be in the fossil fuel. If you burn it, that will be released into the atmosphere. Whereas in the biomass enagutte, let's say a plant. So during the growing of plant, it will act as a carbon sink. You know that they will respire, they will take in carbon dioxide. So the carbon will be saved into the plant during its growth, right? Later on, when you decompose the plant to generate biomass energy, that carbon will be released, right? So the difference is, fossil fuel alli they are releasing the energy stored millions of years ago, whereas in the biomass they are releasing the carbon which is stored when it is grown, and within 100 years. So within 10 years, when the carbon is captured by that, only that carbon is released, whereas fossil fuel older carbon is released. That is the difference. See, when the older carbon is released, it will increase the carbon dioxide, it will cause carbon dioxide imbalance, whereas biomass only recent carbon, it won't cause much imbalance, right? This is the concept, right? So with respect to biomass generation, we have many processes called many chemical processes called gasification, combustion, pyrolysis. Gasification means what? So it means generation of gas. So under gasification, you have one concept called anaerobic digestion or biomethanation. What is anaerobic? Without oxygen, without air, if the energy is generated, that is anaerobic, also called biomethanation. What happens? This biomass is you put it in a place. So what happens? There will be lot of microorganisms. These microorganisms, this will decompose the biomass. It will biodegrade the biomass, and it will release the methane gas. So methane rich biogas is released. What is the formula of methane? CH4. CH4 is released. So in anaerobic digestion or biomethanation, they are releasing the methane gas. So that is why this process is called as methanogenesis. What is it called? Methanogenesis. Then you have one more concept. Next concept is energy generation is combustion or incineration. So in Punjab farmers, so why Delhi experiences pollution during the month of October, November, December andre? So see, Kharif ali they will grow the rice or wheat. Adanna en ಮಾಡ್ತಾರೆ, they are going to harvest it, within 15 days they have to grow new crop, rabi crop. What they will do, stubble andre ಏನಂತಾರೆ ಪೈರು ಅದನ್ನ ಕಟ್ ಮಾಡೋದಕ್ಕೆ they don't have much time. What they will do, burn it. So that is a form of combustion, but it will lead to a lot of pollution. So combustion or incineration alli, that biomass is burnt in excess air. Andre lot of air will be in excess amount of air and oxygen. The biomass is burnt at very high temperature. It will give heat, gas and ash as the byproducts. See, when you burn the biomass, what happens? Heat is generated. That heat can be used in sugarcane factory. Alva. Sugarcane factory you can use it. And also in brick making. Brick making alla idin itke base bekalapa. There they can use it. And even in alemane they use this biomass. Alemane they will bake this thing, no, sugarcane juice. So there also they can use the biomass to produce energy. That is combustion. Then is third process is pyrolysis. Pyrolysis or gasification. So pyrolysis, what do you mean by pyrolysis? I told yesterday. Burning in the absence of oxygen. Burning in the absence of air. So avagenagutte, when you burn with absolute absence of air, there is no air, it will give you charcoal. Charcoal, or in other times, woolnella burn madre without oxygen, it will decompose and it will give a particular type of gas called syngas. What gas? syngas. Syngas is very important. Synthesized gas is also called as syngas. Please write down. So syngas is produced in pyrolysis. Then one more type of gas is there, producer gas. So what is the difference between syngas and producer gas? Syngas is produced when you burn it without absolutely no oxygen and air. Producer gas is produced when you burn it with limited gas, limited oxygen. You are going to burn it, it is going to produce the producer gas, right? So in producer syngas alli there is total combustion, total decomposition. Producer gas alli it is manufactured with little oxygen or little air. There only partial combustion takes place. Only partial combustion takes place. This is all about the biomass. Next we will focus on cogeneration. I have told you cogeneration yesterday. What is cogeneration? You tell me. Louder. Yes, using of the same energy twice. Nordic countries, didn't I tell you? So there is this spring. From the spring you will get this geothermal energy, right? Hot water springs. From that the gas will come and they are going to turn the turbine and produce energy. And the same gas is given to, the same steam is given to houses and industries, so that it acts as a heater, right? So that is cogeneration. Two energy from one fuel. Two energy from one fuel. So the first form of energy is always heat. One is heat. Second can be anything, mechanical or electrical energy, right? So in India we have bagasse based cogeneration. What is bagasse? BAGASSE. How do we get the bagasse? Sugarcane. From sugarcane, sugarcane do idiruttallappa satte. Once the sugarcane juice is extracted, the waste, that is bagasse, right? BAGASSE. Bagasse based cogeneration. That will produce heat also. That can be produced for electricity also, right? So with respect to cogeneration, what is the capacity? Andre, we have 300 megawatt of capacity. Not 300, maybe 300 gigawatt of capacity from biomass. Okay, we are talking about biomass based cogeneration. From the biomass, if we are generating the energy, so we can generate 300 megawatt from cogeneration. Biomass, heat, biomass, electricity, same fuel, two energies, right? So with respect to cogeneration, there is one more concept, same thing. So we are mixing the normal fuel with biofuel, alva, biodiesel, biopetrol. So they are aiming to mix 20% diesel with 20% diesel. ಈಗ 100 liter diesel idre 20 liter will be biodiesel from the biomass, right? So that they are aiming by 2030, 20% diesel and some 10% of petrol ansutte. So they are andre mixing of normal fuel with biofuel. They are aiming to do that in order to reduce the fuel import, so that can be done. The fuel prices will come down, right? We don't know. That is all about the cogeneration. Next, we will talk about waste to energy. Waste to energy. So we have, see, the major part of waste to energy is solid waste, garbage, municipal garbage, industrial waste that can be converted into energy. So you have this waste in the landfill. You know, right? Landfill. Yesterday I have discussed various types of landfill, land farming, right? So another type called the sanitized landfill and dumping, all those things, open landfill, all those things yesterday I discussed. So when you move the waste from the landfill and generate the energy, that is waste to energy. So what is the potential of that? So we can generate sewage. So you know the sewage, right? From sewage itself we can generate 225 megawatt of energy, it seems. 225 megawatt of energy just by the sewage. So that is liquid waste. Solid waste in that there can be many things. So with respect to waste to energy, we can, I am saying 225 can be generated, but there are a lot of problems in generation. One is we don't know the technology of generation. Western countries have technology, they are not giving us. So that we don't know. Then the initial setup cost is very high cost of setup. Then one more problem is, the major problem is, see, even though in Bangalore they have made this scheme, dry waste, wet waste, how many of them are following? At our apartment we do follow it, but I don't think they are following it everywhere. So even though they keep 2 dustbin, wet waste will go into dry waste will go into wet waste. So that awareness is not there in the public. So no segregation, and also there is no policy support. Waste to energy policy is not yet there, right? There is no appropriate policy, right? Okay. Then we will, so ocean thermal energy we discuss. Next we will talk about the geothermal energy. So you know what is the geothermal energy? So where is the heat? Geothermal andre thermal, heat from the earth. So where do you find the heat in the earth? Which layer? Magma, asthenosphere, you are going to find the heat. How does magma hege barutte electricity, I mean the heat? From the decay of radioactive material. Radioactive material gets decayed and produces the energy in the magma. So where do you find the geothermal energy? Let's say this is the earth. So this is, let's say this is a part of the earth. So here there is a magma layer. So here there are plates, right? So at the boundaries of plate, this geothermal energy can be found. So at the boundaries of plate, not everywhere, at the plate margin. So how do we capture this energy? By hydrothermal convection. What is hydrothermal convection? See, what happens here, let's say there is a lake. So here there is a plate boundary, this water will seep to the magma layer. So here there is lot of heat in the magma layer, the water will become vapor because of excess heat, and it is going to come out in the form of a heat, in the form of a steam, high pressure steam. So water will seep into the magma layer, become a gas, and it is going to come out as a steam, right? That is the concept of geothermal energy, and this concept is called as hydrothermal convection. Convection andre no, transfer of heat from one layer to another layer. So from hydrosphere, water goes to magma, asthenosphere. From there, it is going to come back to the crustal layer. That is the hydrothermal convection. So what is the potential of geothermal energy in India? It is 11 gigawatt. 11 gigawatt. That means we have lot of potential. We have 340 hot springs. 340 hot springs in India. So how does a hot spring looks like? I'll show you. So I'll show you hot spring in the Yellowstone National Park. There is one Yellowstone. Where is Yellowstone National Park? USA. Hot spring. So only there are lot of hot springs which are giving energy, this heat always. Hot spring in Yellowstone Park. See. So this is how it is. This is a hot spring. So so the water will be warm, very warm. So in some places there will be a tunnel. From the tunnel there is huge gas. I mean steam coming at high pressure, right? So then I will show you a hot spring in Norway as well, because they are very beautiful. Just look. Yeah. See, this is Norway. In Norway also you will find lot of hot springs. This is not man-made. It is actually, it looks like man-made, but it is natural. So these are the hot springs in the. So how do we geothermal energy? It is not from hot spring. It is from the geysers. Geyser Yellowstone National Park. So geyser andre, this is how a geyser looks like. So the energy gushes out. The steam will gush out from the earth. This is what a geyser looks like. Okay, clear? So India has 340 hot springs. There are many types of hot springs. One is orogenic hot springs, that other is non-orogenic hot springs. Orogenic hot springs andre those which are in the mountain region. Where do you find the hot springs? You will find it in Himalaya. Himalaya you will find it. You will find it in the Andaman and Nicobar. You will find it in the Naga Lushai Hills. Where is Naga Lushai Hills? Naga Hills, Lushai Hills. Lushai Hills is also called as. So Naga Hills, northeast Alvenappa, Naga Hills, Lushai Hills. So that is what I am asking you. So Lushai Hills, I think Lushai Hills also called as Mizo Hills or Manipur Hills. Lushai Hills also called as, just let me check out Lushai Hills. So it is also called as Mizo Hills. So these basic information you should know here. It is Mizo Hills. There you will find the hot springs, right? So there are many sites. So you have important sites. Yaudu in Jammu and Kashmir you have Puga, where these hot springs you will find. Then you have very important Tattapani. There is a geothermal plant. First geothermal plant in India, Tattapani. Where? In Chhattisgarh. Chhattisgarh you have Tattapani. Sorry, Tattapani is in Himachal Pradesh, not Chhattisgarh. I have written it wrong. Tattapani. So it is in Himachal Pradesh. Tattapani in Himachal Pradesh. That is where the first plant is done. Then Jalgaon. Where is Jalgaon? Maharashtra. There also you will find geothermal energy. So what are this is about the plant sites of geothermal energy. What are the challenges? Challenges in generating the geothermal energy. One is high generation cost. The generation cost of energy is very high. Second, drilling cost is high. You have to drill it ala. Drill it to that depth from where the energy will gush out. That drilling cost is high. Then there is a transmission barrier. Transmission barrier and see all these geothermal vents or these geysers, they are located in mountainous areas. From there, it is difficult to transfer the energy from there to land, plain land. That is one thing. Then accessibility. So all these are in difficult places, difficult terrains. It is actually difficult to go and access these places, right? So these are the this is all about the ocean thermal energy. So the last type of renewable energy we are talking about is fuel cell. So fuel cell, it is an electrochemical device. It converts the chemical energy to electrical energy. The most prominent form of fuel cell is hydrogen fuel cell. So I'm going to show you the image of a fuel cell. So this is how a hydrogen fuel cell looks like. There will be one oxidant layer, one water layer, hydrogen gas, and all these are not important. So recently what happened, there was a information, see this is how it looks like. So from one side you will get oxygen, from one side hydrogen, excess hydrogen goes from here, this oxygen, because water, protons come from here, hydrogen molecules come from here, it will mix with the oxygen and water will come out of here. Here there will be catalyst, in the middle there will be electrolyte, there will be two nodes from which electricity is generated. Recently one information about the recently there is one incident happened in parliament with respect to hydrogen fuel cell. What is that incident? Our road transport minister Nitin Gadkari went to parliament in a hydrogen fuel cell car. Hydrogen fuel cell car and Nitin Gadkari. So that's a very good thing, yeah. This is the car. Where is it? Hydrogen fuel cell car. I saw that. See, this is the car. Nitin Gadkari rolls into parliament in hydrogen car. So see, car also looks nice. Which company it is? Toyota hydrogen fuel cell car. So if you are planning to buy a car, go for an electric car. Don't buy diesel car. Diesel cars will be outdated in next 5 years. It will be already. See, already you have this Tata Nexon, you have MG, you have Hyundai Kona, all these cars. MG ZD SV, I think. So MG and Hyundai Kona gives mileage more than 430 kilometers for one recharge. Nexon gives some 340 kilometers. So another 2-3 years, definitely there will be electric car. If you recharge it one time, you can go up to 500 kilometers. Good enough. So if you recharge it one time, if you go for 500 kilometers, it's good, right? So don't buy a diesel car. Okay. So this fuel cell, there is no combustion. In fuel only, it is only because of electrodes. There is no combustion, no fire, no fuel and no use of fire. So fuel is hydrogen. So the energy conversion. So from the hydrogen energy, the total energy that is generated, the energy conversion efficiency is 55%. Whereas in the fossil fuel, the energy conversion is much less. Whereas hydrogen fuel, the energy conversion is 55%, which is very good conversion ratio, right? So it will reduce the pollution as well. There won't be the only, see, I showed you the hydrogen fuel cell diagram. The only thing that comes out is water. So there is very less pollution, right? So this hydrogen fuel cell can be used for decentralized power generation. Let's say Siachen Glacier or some tribal village in some remote place. So there you can't
extend the power line, electricity line. So there what we can do, we can install a hydrogen fuel cell plant. From that fuel cell plant, they are going to generate the energy and use it, right? That can be done. So what is the cost of hydrogen fuel cell? Andre, it is, what is the problem? Andre, it is costly. Cost is the limiting factor. Then we will talk about the last concept under the renewable energy topic is REN21. REN21, it is a forum. It is a global renewable energy policy multi-stakeholder network. It is a network of countries. ಯಾವ countries renewable energy interest iro countries. So it includes both governments, it includes private sector, it includes international organizations, it includes public, everybody, it includes industry, everybody is under REN21. It is a grouping, it is a network, right? So what does it do? It gives policy information. It also undertakes research, policy and research. So this is all about the REN21. With that, I am going to conclude the renewable energy chapter. We will move towards the environmental issues. So environmental issues per se are not like very important from the preliminary perspective, but you should have a broad understanding what is happening where in the environment, Indian environment. So whenever we talk about the environmental issues, the first area of concern is Himalayas. Himalayas, there are lot, Himalaya, it is more than 3000 kilometer length and approximately 250 to 300 kilometer breadth. So it forms a barrier from India to Central Asia. So we have discussed the importance of Himalayas in the geography, how it blocks the monsoon, how it blocks the cold air from the Siberia, all these things, how it divides the westerly wind into northern branch and southern branch. So all these are the importance of Himalayas, but unfortunately Himalayas are facing lot of problem. So first we will look at the services provided by the Himalayas. It acts as a water reservoir, right? All your rivers are originating from the Himalayas. That is one thing. Then it acts as a carbon sink. So there it will take the carbon and store it. Carbon sink. Then it acts as a biodiversity hotspot. Himalayas is one of the biodiversity hotspot. In fact, the northeast Himalayas is one of the hottest hotspot. Hotspot andre the diversity, the number of animals and plants is, variety of animals and plants is very rich, right? That is the services. Not only that, meteorological services, blocking the monsoon, blocking the cold air, dividing the westerlies, directing the easterlies, right? Blocking the cyclones from the Bay of Bengal. All these are the work of the Himalayas. It is very, very important. So then now we have see, because India is called a tropical monsoon climate. Why? Because of Himalayas only. If Himalayas were not there, northern India would be ice packed, right? So now it is becoming vulnerable. There is lot of stress on the Himalayas. So what are the various problems? One is urbanization of Himalayas. Himalayas, there are lot of cities that is being built. So for example, last month I visited Mussoorie in Dehradun. So there is lot of cities. See, there is lot of, I thought Bengaluru traffic is the worst traffic, but when I went to Mussoorie and when I went to Uttarakhand, Dehradun, the traffic there was much worse than Bangalore. Why? The problem is the roads are very small, right? So that is one thing. And there is lot of urbanization. You will find these resorts, you will find this roads, you will find industries, you will find hydroelectric power plants. All these are hampering. Not only that, there is solid waste being discarded. Andre waste, plastic, garbage, all these things are being discarded. So why these tourists go? They will take a packet of chips and maybe some alcohol also together. They will drink the alcohol, eat the chips, throw it there. They are not going to carry it together, right? Because of tourism, the waste is increasing in the Himalayas. That is one thing. Even the mountaineers, Mountaineers andre those who climb the mountains. They are going to carry with them so many things, right? Food packets and everything. They eat the food, throw the packet there. Who is going to clean it? It will remain there. See, if they throw it in the land, somebody from BBMP so will not pick up. So somebody, at least some NGO, somebody will go and clean it and clean it and put it in the dustbin. If you throw it on the mountain, who is going to pick it? Right? So that's why I advise you, don't throw waste anywhere except dustbin, right? Dustbin. So that is one thing, solid waste. Then town planning. The classic example is the road between Mussoorie and Dehradun. And in the town, the roads are very small. There is, the town planning is not good. They are planning it unsustainably. Andre ek bekage construct ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತಾ ಇದ್ದಾರೆ. It might lead to landslides, right? Whenever there is landslides, all these houses will collapse. So they are doing deforestation to build houses there. So which is very bad, right? Then they are planning, they are constructing unscientifically roads, industries, all those things. That is one thing, that is the problem. Then what is the initiatives that have been taken? So they have banned plastic in Himachal Pradesh with respect to solid waste. When was it banned? There is complete ban of plastic in Himachal Pradesh. When was it enforced? Important. 2009, there is a ban on plastic in Himachal Pradesh. Then you have lake conservation. In the Himalayan topography, they are conserving the lakes. Lot of lakes are being conserved. So it is called as participatory conservation of lake. What do you mean by participatory conservation? That is, citizens, civil service society organization, they are going to participate in the conservation of the lakes, right? So the best example is in Nainital. Where is Nainital? Which state? Uttarakhand. So there is one, Nainital gets its name from the one lake called Naini Lake. So that Naini Lake, because of tourism, because of the excess exploitation, unplanned urbanization, it was polluted. So they carried out a program called Mission Butterfly on Naini Lake, right? So Mission Butterfly, they carried out and cleaned the lake. Even today, it is not allowed to throw waste in the lake, and even the private sector, the tourism industry, they are cooperating. They will give the waste to the municipal waste collector. So all the waste is being collected, right? Then you have the conservation in the Dal Lake. So Dal Lake, where is it? Srinagar. Dal Lake, Srinagar. So there it comes under the lake conservation program of the Ministry of Environment, Forest and Climate Change. So this Environment Ministry has a lake conservation program under which Dal Lake comes, right? Not only that, when it comes to town planning, under Jawaharlal Nehru National Urban Rejuvenation Mission, JNNURM. So all these buses have JNNURM written on them, right? In Bangalore, it was written earlier. I don't know whether it is removed now. JNNURM, under that, they are planning to have a planned urbanization. Urbanization has to be planned. Okay. So with respect to solid waste management in Himalayan region, what can be done? What are the steps to be done? One is, solid waste can be prohibited. Andre, throwing of plastic can be prohibited. Then we can have data can be collected from where all solid waste is being thrown. Data can be collected. Then we can convert the waste. Solid waste can be converted into energy. That can be done. Then you can use the 4R principle. What is 4R principle? Reduce, reuse, refuse, recycle. Those they can be used. Then we can increase the awareness among the people. We can implement the best practices across the world. ಬೇರೆ ಎಲ್ಲಾದ್ರೂ ಈ ತರ ಈ ಪ್ರಾಬ್ಲಮ್ ಇದ್ದಿ, if they have reduced the problem, we can emulate the same method in India, right? So that is with respect to solid waste management. With respect to planning, what steps can be carried out? One is, there should be no fragmentation. Andre fragmentation andre land is, some part of land is used, some part is wasted, right? So there is no scientific planning. Scientific planning has to be carried out. And then in hazard zone, where there is landslide, where there is earthquake, right? In those zones, construction and ecological hotspots, where the tigers and elephants and the leopards roam around. Those places, construction should not be allowed. Then there should be focus on aestheticity. What is aestheticity? Beautiful, beautiness. Aesthetic means beauty of a place, that should be preserved. Then deforestation should be stopped. Then there should be an integrated development plan of a urbanization. Integrated development plan andre, so it includes environment, it includes economy, it includes society. So all the transport infrastructure, everything should be taken together and build a plan for the development. That should be there. Then we can build earthquake resistant buildings in the region. So that is also a sustainable development. Then you have, we can use location specific technologies. Andre, some areas where earthquake is high, we can use wood based buildings, right? Some area where there is lot of landslides, we can build barriers to landslides, right? Wall to landslide. So landslide will get accumulated behind the barrier. That can be done. Then also roads can be, green roads can be built in the Himalayan region. So next is, regions are very famous for tourism, especially religious tourism. So what are the religious places? We have Kedarnath, Badrinath, we have Vaishno Devi, we have Amarnath caves. Can you name some? Haridwar, what else? Gangotri, Yamunotri, Kashi. Kashi is in Himalayas. Kashi is in the plains. Prayagraj. Right? So all these are the, what is the other name of Kashi? Kashi has got 3 names. Where is it? Okay, Kashi, where is it? Uttar Pradesh. At the confluence of what river? Ganga and Ganga, Yamuna and one more river. Saraswati. Do we see Saraswati today? It is not visible. Right? Earlier name of this place is called Allahabad. Now it is called what? Prayagraj. Right? So what is the other name of Kashi? Varanasi. There is one more name. Banaras. So you have the famous Banaras Hindu University, right? When was it started? 1916. Who started it? Madan Mohan Malviya, even Annie Besant played her part. Banaras Hindu University. Okay. All these are general knowledge information. So these Himalayas are called as home of saints, right? If you are frustrated with life, leave everything, go to Himalayas, right? Okay. So you have a lot of Himalayan yogis. Is it good to go to Himalayas? See, I personally feel we should face the challenge of life here itself rather than running away to Himalayas. Especially if you have some religious ideas, if you want to achieve enlightenment, if you want to get closer to God, you can go there. But I don't find it is useful. Okay, let it be. Let's not get into that. Okay. So what are the with respect to tourism, what can be done in these places? So there are a lot of problems with respect to tourism. There is no road, there is no hotels, there is no proper infrastructure. Logistics problem is there. Then there is no regulation. And these tourists, they will create all sort of nonsense. They will throw the waste. They will go to places which are prohibited. That is there. There is no regulation. Then they are going to harm the environment and the local culture. So Himalayas has lot of local culture. There is Tibetan culture. When it comes to Srinagar, there is Kashmiri culture. When you come to Himachal and Uttarakhand, there is proper Hindu culture, right? Hindu religious culture, right? So what we can do in order to protect the culture along with the ecology, andre we can promote community based tourism. What is community based tourism? Andre local people na we have to involve in tourism. See, there will be local people, they should be taken into policy making. They should tell what is good for them, what is bad for them. They should tell how many people should be allowed to visit per day. They should provide the facility, hotel and lodging and food facility. Community-based tourism can be promoted. So, one is, what are the initiatives? One is harness religious sentiments. Andre, harness religious sentiments. Andre, see, all these places are religiously sacred. So, we can tell, sorry, we can tell the people, see, it is religious is sacred. If you throw plastic, you will be born as a pig in next life. Right? So we can scare the people using religious sentiments. That is one thing. Then we can promote eco-cultural landscape. Andre, ecological and culturally, we can make certain landscapes. Andre, certain regions. We can follow this circuit-based tourism. Andre, circuit-based. Andre, certain religious places can be made as a circuit, as a eco-cultural landscape, and there can be package tours that can be done. Then there can be sacred groves. Sacred groves, andre, certain places can be prohibited from visiting because it is sacred, right, where the god resides. That can be done. So in this direction, there is one program called Himalayan Homestay Program. The localites are providing homestay facility. Himalayan Homestay Program, it is a community tourism program in which youth of the place will act guide for the tourist. You have seen this movie Kedarnath. Kedarnath is a movie by Sushant Singh Rajput, right? There he acts as a guide in the region, right? Okay, then you have one more policy, Sikkim. In there, Sikkim ecotourism policy is there. In the Sikkim region, what they do, they see, if you visit a place, you have to return within this many hours. If you visit some sacred place, you have to return within 2 hours, and also you have to pay the fees to go there. Suppose you put some dust or plastic there, that fees will be used to clean that place, right? That is there. Then also, in these places, not only a cultural and ecological tourism, adventure tourism can be promoted. What is adventure tourism? Mountaineering, trekking, right? All these things can be promoted. See, when it comes to the current affairs with respect to Himalayan tourism, there is one project called Charadam Project. What are the Charadams? Two more. Gangotri and Yamunotri. Gangotri, Yamunotri, Kedarnath and Badrinath. Let me show you the map, because without the map, it is difficult to understand. It is called Chardham Circuit. Chardham Circuit. So this is a circuit. So it is from Badrinath, Kedarnath, from there to Gangotri and Yamunotri. This is the circuit, Chardham Circuit. Okay. So this is about the tourism. So in Gangotri, there is a policy. What policy? Per day only 150 people are allowed. Not more, 150 people will be allowed to travel to Gangotri Glacier, Gaumukh Glacier. Which river originates there? Which tributary? Alaknanda or Bhagirathi? Alaknanda originates in Alakpuri, yaar. It is Bhagirathi which originates there. Alakpuri originates Alaknanda, right? Where do Alaknanda and Bhagirathi merge? Devprayag. Devprayag in Uttarakhand. So where does the Ganga river hits the plain? And right, it will be flowing over the mountains. Plain region ell enter agutte. At which place? It's also a famous place. Haridwar. Haridwar, it's the plain. Okay. So what should be, so tourism, how do we regulate the tourism? One is, tourism places should be developed also, they should be regulated also. Both should be there. Then we should provide ecologically safer routes, and there should be roadside drains. Why roadside drains? If there is floods, if there is no drain, the road will collapse. So roadside drains idre, it won't collapse. That can be done. Then roads can be built by bioengineering. Bioengineering is use of biology, right? Biological or technology in engineering. Geoengineering can be done. Then we can use cultural and natural pilgrimage. Both of them can be combined. Andre ಸಾಂಸ್ಕೃತಿಕ ಮತ್ತೆ prakrutika ಎರಡನ್ನು combine ಮಾಡಿ we can have a tourism policy. Then we should have a garbage disposal policy in the Himalayas. Then we should have data of the tourism places. Then we can promote ecotourism model. Ecotourism means environmental tourism, right? That can be promoted. So it includes traveling to the environmentally rich places, naturally rich places also. Not only that, it includes traveling to, having a ecotourism. Andre, you are not putting any waste. You are using electric vehicle or CNG vehicle to travel. That is the ecotourism model. Local participation can be, local people should be involved in tourism. Then local culture should be promoted. I have told you local cultures. Then we should promote adventure tourism and it should be regulated also. Why adventure tourism should be regulated? So adventure tourism, see, they go to Himalayas Allah. So there was one time, some in 2019 or some time, where people went there. There was a huge avalanche and lot of the people died. So they don't respect the nature. Nature is going to kill you, right? So adventure tourism should be regulated. Then groundwater recharge should be done in these places and the places should be cleaned. There can be policy of social fencing. Social fencing andre some places should be warded off. Andre some places should be prohibited from visiting. So during COVID in Arunachal Pradesh, there was social fencing. Andre people themselves prohibited tourists from visiting during COVID in 2020 in Arunachal Pradesh. That can be done. Then there can be one more policy called spring sanctuary development. There are a lot of hot springs in this region. So those sanctuaries can be developed, right? That can be done. Also rainwater harvesting can be done in this region, right? Okay. So next we will talk, this is all about the tourism in the Himalayan region. The last topic of the day, very, very important topic. We will talk about the sand mining in India. Sand is what? Is it a major mineral? Is it a mineral in first place? Is it a mineral? Sand is a mineral, right? It includes various types of elements like quartz, silica, all those things, right? Sand is a minor mineral. So what is the use of sand? Right? Environmental use. Don't tell it is used in construction. What is the environmental use of sand? First of all, it is a mineral. It includes lot of minerals within it. Then when there is a sand in the coastal region, it will prevent the waves from reaching the land. That is the next use. Then it acts as an aquifer. Andre, this sand holds lot of water. So it recharges the groundwater. So sand, and if you if you go to some river and take the land, it will be very heavy weight. Why? Because lot of water will be there. That is why it acts as an aquifer. It stores the water. In sand, it promotes lot of biodiversity. In that river sand only, there will be lot of animals and plants which are growing. Right? It promotes biodiversity, and because of sand, there is promotion of tourism also. So there is no single kid which doesn't like to play in the beach, right? That also it is there. Then it so these are the uses of the sand. So what other uses you have? The sand, one is it enhances the beauty of the nature of that place that is there. Then it promotes biodiversity, and it acts as a, sand acts as a barrier for the river. So rivers channelize the river in a particular direction. These are all the use of the sand. So, but we are having the issue of sand mining. So in order to do construction, people are illegally extracting the sand. So they want to do constructions, right? So they mix the sand with the cement and do construction. That is why there is lot of illegal sand mining. But Supreme Court has said that if you want to do the sand mining, you need clearance. You need clearance from the respective state governments. Also, Supreme Court has imposed limits on sand extraction. So, only this much should be extracted. Anta. So, what are the effects of sand extraction? What are the environmental and other effects? One is it leads to groundwater depletion. Groundwater, if it doesn't recharge, groundwater will die. Right? So, this example you can see the Papagani River. Where is Papagani River? Between which states? In which state it is there? Papagani. It is in Karnataka and Andhra Pradesh. Yeah, it flows from Karnataka to Andhra Pradesh. It is a small river. Papagani River, they have extracted the sand. So groundwater has been depleted in the Papagani River. Then it is a revenue loss for the state. State wants revenue from the sand. It is a mineral, right? State imposes tax. If they illegally extract the sand, it is a loss of tax for the government. That is there. Then what are the environmental causes? One is when groundwater depletion, that is the environmental cause. So it will lead to less drinking water, that is there. Then see, when you extract the sand, what happens? So if the river is flowing in one direction, if you extract the sand, what happens? The river is going to change its course and cause lot of flooding. Flooding will happen, right? Then it is like if you extract the sand illegally, it is equivalent to robbing the water. You see, that is why you see the tractors which are transporting sand. There will be lot of water dropping from that sand transporting tractors, right? So if you rob the sand, it is robbing water, right? Then lot of microorganisms which are present in the sand, they are going to die. Then there might be erosion in river. There will be lot of erosion because of the sand extraction, right? Then agriculture, the surrounding area, if you extract the sand, what happens? The water level in the river will reduce. So because agriculture will reduce. So you find this example in the Bharatapuzha river region. Where is this Bharatapuzha river? Bharatapuzha river region in the Kerala. There, because of sand extraction, there is no water. So agriculture is reduced. Then coastal ecosystem, if you extract the sea sand, the coastal ecosystem will be hampered. All these are the environmental effects. There are multiple environmental effects. Yeah, there are multiple environmental effects because of the illegal sand extraction. The climate will change in that region. The rainfall will change. So there are lot of direct and even the rock cycle, geochemical cycles will change. So there are lot of negative effects because of illegal sand extraction. So with respect to sand extraction, what are the policies in India? We will look into it tomorrow. We will end the class today here. So any doubts, any comments, please comment in the comment box, or you can reach us on the Telegram channel, VHS Education Forum. Please give us feedback so that we can improvise on our classes. Please take good care of your health. Make good use of the classes. We'll meet again tomorrow. Jai Hind. Namaste.